Hey guys, we're just want to talk a little bit about the new model that I'm working on, the electric version or the electric Cat 336 excavator. I just wanted to go through some of the ways that I've built this and reinforced it and things like that. Uh, I can't really show you guys some of the things inside of here and in here because I mean I can show you guys. I won't show you now because I already have it together and I still want to test a few things. Still testing out these cylinders and some of the other parts and all that good stuff. But what I really wanted to talk about today is how I did the slew setup in here, and it's all 3D printed. It's just supported by 3 bearings. You have 2 regular ball bearings, just radial bearings, and then you have 1 thrust bearing, which is if you guys don't know what it is, let me see if I can. Here it is right here. Well, here's one. So here's I'm using 2 of these guys. Okay, that's going to be for our pin, and that pin I'll show you guys what I'm talking about later on. And then this is a thrust bearing, and the thrust bearing is just, I don't know if you guys can actually see this far over, but the thrust bearing is just 2 plates, 2 washers essentially, sandwiched in between a needle bearing setup. And they call it a thrust bearing because what it is you apply pressure on both sides, and it allows it to still roll really nicely and freely. Okay, so this is for the house. Okay, when the house gets bolted down, it sits on this and it allows it to spin nice and freely. This is to just make sure that the house pin, or the I don't really know what to call it, so I'll call it a keen pin for right now until I can figure out what it's actually called. But the keen pin is just 2 plates. So for, I don't have the other pieces, but here's going to be 1, and then there's 2, and then the pieces that are actually in there are going to be much thicker. But that's going to be what your keen pin looks like. And what happens is this gets bolted like that, and then this top part, the house, gets bolted onto this. And then this, the bearings are, there's 2 bearings inside of there to make sure that it stays perfectly center. Okay, and then that gets bolted into the undercarriage here. And what it allows is the undercarriage to kind of grab onto this pin. This pin is now locked up into here as well, and nothing can move. So that was the idea on that. And to be honest, I didn't really have that wasn't my idea. That was a gentleman, I hope I'm saying his name right, Matthias Joner, or Joner. He's the one that did the some mods on the actually he did the mods on the undercarriage for my KX080, the Kubota. And what I did is I just ran with that idea, and I hope that was okay with him. I kind of thought it was a generic thing. But I took that idea and I just enlarged it and then made it work for this guy. And same with my Volvo, the EC300. And it works very well, the whole slew setup. It's super basic, it doesn't cost much, and it uses all 3D printed parts, and I haven't had any issues with it. And you can see I have all my weight back here. I don't know if you guys can see all of it in the counterweight. And that adds, I'm not too sure how much this weighs just yet, but we'll wait later on. But I'm pushing down pretty much not as hard as I can, but I'm pushing down hard, and it's just lifting right here. And then if you guys can see, it stays relatively straight. I mean, I believe some flex is normal. I've been watching a lot of the Gold Rush shows or seasons, and just watching the machines and all that. There's going to be a little bit of deflection, especially with how long this is. Looks like I need to shim it actually. or tighten something down. Because I can see it moving around here. Well, I'm going to take it apart, or take it off anyways, to show you guys what's going on in here. But I like this setup. I think it's really, really nice. The Volvo is much tighter. I'm still messing with the tolerances in here. I've made some shims, 0.2 millimeter shims. They're really, really thin, but it allows me to kind of fine tune it and make sure that this is eliminated at the end of it. And that shim actually that I added might be messing with it. So the arms are, each side is 3 pieces just because of how big they are. They don't use any metal. What it is it's just, you can kind of see that it's like an L shape or S, and it gets bolted together via these countersunk or counterbored holes. And then the actuator mounts, this really helped me when I was testing. And if any of you guys watching model your own machines or anything like that, this may help you too. But I figured that this was the easiest way for me to not have to keep reprinting these arms. So what I did is I printed pieces or modeled pieces like this. This isn't the one. Here is one of the test pieces. I printed pieces like this, and what happened is they get bolted in here, and it allowed me to just mess around with the mounting points for those cylinders. But what I ended up figuring out too is this is a very good way to do things. Because let's say that you're going to use these metal pins. This isn't the pin I would use, but this is just a all thread. But you're going to use this all thread or your rods, your smooth rods, to hold your cylinders in place. And over time, just like the real machines, they're going to get worn. They're going to start to make the bore here bigger. And the same thing happens on real machines. If any of you guys work on machines or work with machines or just watch Gold Rush or any of these, if there's any other shows like that out there, but you can see the wear that happens on these machines, especially if you're using it quite often. And these smaller, especially plastic, it's going to happen, which is okay. Because again, with this model, this is something I really like, is you can change these out. And I know the Volvo, I had 2 different versions of the arms. It was bolt together and then glue together, and the glue was cool for someone that doesn't think they're ever going to have to change it again. But the idea that you may have to change these mounts here, or for me, adjust some things, it was just easier for me to bolt it together. So what happens is it gets bolted together via a bunch of these holes, and I made a bunch of plugs to fill all these. But to be honest, Last came out with that video showing that he made plates to cover the screw holes. I'm not gonna lie, I'm gonna take that idea too and run with it, because that's brilliant. That's a great way to get rid of all these instead of putting all those dowels, because even with the dowels, we're gonna have to sand a little bit just to make it look good. I really like the plate idea. And Last, please forgive me for taking that idea, but I'm going to use that on this. I really, really think that's a fantastic idea. I think you mentioned that it was somebody from your group had mentioned that. So if that somebody's watching, thank you for the idea, and I hope it's okay that I am going to use it on my models too. But anyways, the arm is for the mount up here. It's just going to get a rod as well, a smooth rod. It's going to go all the way through, and then it's going to get held together by, I hope I can find these things. Oh, here we go. So these are actually called, it's called a drill stop, or that's what I've been typing in to find them. And what it is, it just has this bored out for what we're using, a 5mm bore, and then it has a set screw. And then what it does is it allows you to lock your shaft like that. So just to kind of show you guys an example of what it looks like. This is my Volvo bucket, and this is how I have it set up for the quick coupler. But this is the same thing. and this is the 5mm drill stop, and it just allows you to kind of lock your pins in here and be relatively easy to do instead of having to press anything in or things like that. Thought that was pretty cool, pretty easy way to do it, easy way to keep things maintained and take them apart to do whatever you need to do. If you need to change these guys or anything like that. I know this video is going to be a little long, but I just want to make sure that I'm going through everything. So that's going to be your arms. These arms, what I did for the main pivot here is I made these double bearings. So there's actually 4 bearings, 2 on each side, and that really helps get rid of any of the slop in there. And I think it works out really, really good. So that's the arms. The bucket, I redid the bucket better, or not better, but I mean, I guess it's a little better than the Volvo. The Volvo gets, I just updated that, and it gets screwed together. This one, so this one actually uses these. Let me just take this apart for you guys. Sorry, I'm just looking. It uses the M3 bolts, which I think a lot of people are going to appreciate that. There's a couple little guys, M2s up front, but that was just for aesthetics. I mean, not really just for aesthetics, they help. But let me show you guys this one side taken off so you guys can see the inside here. Alright, so what's going on here is this bucket was printed in one piece, this middle part, and then I actually left the cutout here. Again, I wanted to make sure that I had my mounts, I can adjust them, but what it did is it allowed me to add more strength to this bucket. So by being able to replace these or printing them like this, the way I like to look at it is it's like laminating something. Okay, so it's the same thing as this. So if you get 2 pieces and you glue them together, okay, what you've done is in a sense you've laminated them together. Okay, you've created a layer in between that's glue or adhesive or whatever you guys want to call it, and you actually created a very strong layer. Okay, it's the same thing as like this desk or this top here. Okay, this plywood. It's what, 5/8, so 1, 2, 3, 4, 5, 6, 7. So this is 3/4. Okay, so if you just got a piece of, or if you cut down a tree and you ripped it down to 3/4 of an inch, that it's not going to be nearly as strong as a piece of 3/4 inch plywood. And and how that works is so you have 1/8 inch pieces of wood. Okay, and in between each one of those pieces, there's going to be a layer of adhesive. Okay, and that's going to be your strength. So even if you had a 1/4 inch piece of plywood, okay, yeah, that's really, really thin, but a 1/4 inch piece of plywood is going to be relatively strong compared to a 1/4 inch piece of wood. Okay, so the same thing applies with any of this, the 3D printing. Okay, so what we've done here is we've created a piece that was printed flat. Okay, so the idea that it would tear, getting pulled this way, is a lot less than, say, let's see something else. So say you were to print, this piece, I printed it standing up, printing it just like this. Okay, what you've done, I want to find an example. Okay, what you're doing is you've created layer lines going in the wrong direction, in my opinion. Okay, so stress, you could grab, let me grab a piece that I'm not going to use. So you could grab that piece that was printed standing up, and then you could break it relatively easy. Okay, but one of these, I wish I had another way to test the strength of it. One of these, let's do this. This is going to be a heck of a lot stronger because in theory, not in theory, but in essence, it's laminated together. It's a bunch of thin layers laminated to each other. Okay, so let's All right, so I broke that one, obviously with some pliers. Okay, so how that broke though is very much different than it would break if it was the other way. Let me see if I can find a piece that I've printed that was standing up, like a cylinder or something. Give me a second. Here's a perfect example right here. Okay, so this was printed standing up, right? Okay, so I could break it just like that. Okay, so look at the way that that broke. It broke along the layer lines. Okay, so that's going to be something that, like, if you were to design something that stood up like this and it needed, it only got bolted from down here, and there was going to be, this possibility that this could move, this would probably break. Okay, but if you were to print this, something like that laying down, okay, then you're creating, again, the laminate theory, I guess. And the idea that it would break going this way would be much less likely because of the way that was printed. Okay, so the same thing applies to all of this. I know this is going to be a lengthy video, and I just want to help people that are new understand what's going on here and how I do things. So that's how I've done that, and again, it makes for a really, really strong part. Okay, so obviously I was able to break this one, but I wish there was a way to maybe, let's see if I can break this part, and we'll show you guys. See, I can break it. Gosh dang. There we go. But you see how much force I had to put on that? This was printed at 70% and five layers, or five walls. Yeah, the hole is still very, very good. And anyways, you're not going to really ever have that much force. I just put so much force on that. Okay, and then this is just one of them. You have two here. Okay, so the idea that something would be able to create that much force going sideways is not likely. I mean, it is, I guess, if you're doing it with your hands, a big old giant messing with these machines in real life, sorry. But I think this is a good example. So this makes this bucket really, really strong. Okay, even if you printed this piece, sideways like that, you're probably thinking like, well, it can just kind of snap, in half. Well, not really, because we have these pieces sandwiching it, right? And what you've done is you've added some shear strength to this. Okay, the ability and what shear is you get these walls, these outside walls here, and then these walls as well. Okay, what you've done is you've added shear strength, and shear is to where it can't twist or rack. Okay, so if you build a box or a wall, with just four sides like this, okay, and it can still kind of go like this, and that's probably a bad example, but that's called racking. Okay, so to prevent racking, what you would do is you'd put we call it a shear wall. Okay, so you'd put something like a wall behind here. Okay, and then what that would do is prevent it from racking this way or anyway. Okay, so the same thing applies to all of this. Okay, so the bucket, this bucket is very strong. Okay, so what holds these two pieces in is going to be two 3mm rods. Okay, I wanted to add 3, but I couldn't up there. But which is fine as long as these mounts don't move. It's great because we have our pins that are going to go through here on each one, kind of like that bucket I showed you earlier, and it's going to lock it in and be great. The forces that we're going to be applying to any of this is going to be far less than what I can do with my hands. All right, so stick arm, the same way. You got your 4 bearings down here. Did I put 4 in there? Yeah, 4 bearings up on each pivot, and then 4 bearings here. So just in this alone, it has 12 bearings. And that's just to make sure that everything moves smoothly and moves great. Cutout here is going to be for the limit switches. We'll talk about that in the build video. I know this video is becoming very long, and I kind of want to be able to speed through it and still talk to you guys about what I did here. Okay, so the next thing that I want to show you guys is going to be, let's take this house off. So what we'll do is, I know you guys are probably thinking I'm absolutely crazy because there's only 4 bolts here, and that's not going to hold it, but I've done a lot with my Volvo. I could pick it up and shake it by the big arm, and it still holds strong. All right. Okay, so scoot it over here, move these. All right, let's rest this up here. So this is our sluice setup. Here's my spacer. This is actually just a spacer to, it goes right up in here, and it allows this, that bearing, or needle bearing in here, to make contact. Okay, so it looks like there's too much space in between that bearing, and you can kind of see it by this moving around. I don't know if you guys can see that. So this spacer is going to be very important for what we're doing here, and that allows us to do that. So let's. This is where the needle bearing goes, and this is a housing that I printed before, and the needle bearing sits right up in here, and then it gets bolted. It's a bunch of bolts around this, and then that keeps this bearing centered for the most part, and keeps it from wandering or doing anything like that. Okay, we have a metal gear in here, and then a printed slew ring. Now, I modeled this slew ring off of this. This is a metal one that you can buy. I did not realize that the metal one has threads in every hole here, so I wasn't ready for that. Unfortunately, I'm not going to use this right now. Maybe I'll drill these out, but this feels like really good steel. I bought this for the Volvo, and I thought I may need it, but I haven't needed it yet. And I've used that Volvo an awful lot, and it's still holding up really, really well. So maybe it's the size of the gear, but the printed gear here is I think it works really well. It gets bolted in, and this this, we'll call it a riser, gets bolted into the undercarriage for easier printing or quicker printing, I guess, because this undercarriage is actually one whole piece. All right, so here's your keen pin, is what I'm calling it. Okay, so that has the 2 bearings inside of here, and it gets sandwiched in down under here. And then what that allows too is our slip ring will go right up in here, and it gets bolted in, kind of just like the Kubota. It gets bolted in right there. Okay, and that allows us to spin. I don't know if you guys can see, I'm spinning it and keeping the wires the same, and they're not moving down here at all. Okay, so that's what a slip ring does, and that's why we need it to power these motors down here. Okay, I made channels in here that you can fill with weight, and then have covers on here so you can change it or adjust it, whatever you wanted to do. And then these pieces are the same principle as that laminate theory that I was talking about. You know, you have 1, 2, 3, you have 4 pieces right here. One for the motor mount, one for the inside to help strengthen the this up here, and then you have your middle, and then your outside, and then we have our tensioner inside here. Our tensioner is just this, and then it has a 3D printed screen in there, and that is, once these get glued together, this will go in here. And then we have tension. So this will sit more like right here. And you guys are like, oh, what's going on here? Well, the chain's going to go inside here. It's going to be kind of like a guide to help keep the chain in. And then this as well. This gets bolted down right here. And these will help keep the chain in track or in place. So yeah, that's what that would look like. All right. Other than that, and then these are sandwiched in by the just M5, excuse me, M5 threaded rod with some lock nuts. All right. And then lastly, the counterweight. Well, so let's talk about this plate because this thing weighs quite a bit. So these plates, there's two pieces here, and there's 7 8mm rods. And the 8mm rods, they look like this. They're really thick, and they're really heavy. Okay, so what we've done, or what I've done, is a threaded rod, goes right here all the way through one whole piece, and it sticks out a little bit down here for the counterweight. Okay, so the counterweight actually doesn't get unbolted here. If I ever make a bigger one or interchangeable ones, the counterweight actually comes off. All these are magnets as well, strong magnets. So the counterweight actually comes off with these 5 screws. So you take these 5 screws off, and then you pull it off, and then it'll expose all the rods and things like that. Very minimalist as far as all the holes. I tried to make sure that all the screw holes were hidden. My goal when building these are to try and maintain the look of the real machine. And you can see that none of the bolts here are shown. This door is magnets as well. Don't judge me. I know there's a bunch of holes here. I was testing and trying to figure out if it needed all the holes, and it sure doesn't. But again, I just kind of did it like that. And I don't know if you guys are fans of the magnets or if you like the hinges more. The hinges I always break off. I'm just a dum-dum when it comes to that stuff, and it'll be open and I'll go to grab something and it'll just break off. So I really like the magnets. They're strong. They work really well, and it's on both sides. This is stationary, and so is this one. It just gets screwed in. And that's your other side. All right. And there's lots of room. Lots and lots of room inside of here. See if you guys can see. There's no pillars going through the middle. Everything going back inside of here. Very straightforward. Everything's really open. Okay, so you can see down here too. So I'm going to put my pump right in here. Lots of room under here. And then I'm going to get like a pump tank combo. We'll get that inside of here. And then I'll have the valves right there in the middle. And then all my electronics will be up in here. And then this will be my battery area. Maybe extra weight. Right now I think this weighs 10, 11 pounds. So, okay. So that's that. I'm going to just put this back over here. It might not be the greatest of ideas. Just while I'm talking. Alright, so doors, get those over there. Yada, yada. Okay. Throw that up here. Oh, and then this. Same thing with this. This is all pretty laminated in a sense. So you have your middle pieces. Right? Oops. So you get your middle pieces, and then you have your outside pieces. Okay, and that's how that gets built. And that actually makes it, again, really strong. And the idea that we can, if any of these get worn out, the idea that we can just unscrew them and replace them is awesome. I think I think using metal for the reinforcement is a fantastic idea. I just don't think it's necessary. Not saying that again it's not a good idea. I just don't think I think there's certain parts that need it. You know, like this plate here needed the reinforcement for metal. I don't think it needs a plate all the way through. I think it'd be really cool, but I don't know. My goal here is to save money and to make things make it relatively easy to build this. So I know there's going to be metal plates in the future. Obviously, that's going to be one of the goals after I get this done and finally tuned and all that. But let's talk about these. The last thing we want to talk about are these cylinders. Let's get one that's independent. Okay, so this looks like the bucket cylinder. All right, so this is a very simple way of doing things. It's just a DIY linear actuator. The only difference between this and the Kubota ones are this uses the bigger 20 GA motors, and it's a 20 millimeter motor. Been messing with the RPMs. Unfortunately, the only way I've gotten this to work is at 4-cell. And I don't really. 4-cell batteries are really expensive, and I really don't like it. But I figured out a solution to that, and it's a really cheap solution. My buddy showed me this a very long time ago, maybe 15 years ago, when LiPos started to become more relevant. What I have here is two 2-cell batteries, and what I've done is I've made this little setup here, and what this allows this setup, it allows me to run these in series, and what that means is instead of 2-cell, this is now 4-cell. What I've done is I've combined the cells. Okay, so just to help you guys understand, what we're doing is we essentially just made a battery. We've combined two 2-cell batteries into one 4-cell 5,000 milliamp battery. Okay, so there's another way you can do this. I don't know the exact configuration, but it would be the same wires. And this is just a jumper, and then this is just a lead that actually, on these hard packs, it comes with it, something just like that. And that's essentially what this middle one is. It's just one of those, and then a lead with some bullet connectors that I don't really know how to solder apparently. So that's all that is on both sides, and it goes positive to negative, right? Positive to negative on one side, and then positive to negative on the jumper here. Okay, and that allows you, again, the way I have it set up is 4-cell at 5,000 milliamp. If you run these in parallel, you could have you'll still have a 2-cell battery, but you would actually combine the milliamps, so you'd have a 10,000 milliamp battery if you run it in parallel. So running it in series, this allows us to get a 4-cell battery, and which is cheap because not these shorty hard packs, but you can find on Amazon 2-cell batteries at 5,000 milliamp for $20. So we get 2 of those, and then boom, we have a 4-cell battery. So I had to go 4-cell because the 12 volt just wasn't enough. It just wasn't enough power, and unfortunately I wasn't getting any torque out of anything more than 50 RPMs. So that allows me to use the 50 RPMs, and everything's fine. What I'm using are these Keen model. I know a lot of you guys don't like these. I've had nothing but success with them. I think they're great. I just think you have to use the right ones. This is a 20 amp dual motor ESC from Keen model. I'm going to use that for the motors down below. Those are 7 amps stall, which I highly doubt we'll ever stall it, but there's good chances that something might get jammed in the chains or the tracks. So if we ever hit that 7 amp, we don't want to be using what I usually use for actuators, which is like a 5 or 10 amp. We want to make sure that we have enough of that. So both of them are going to draw us 14 at most, and this is 20 amps, so we still have 6 amps left for anything that could occur. So hopefully that's all we're going to need for those. And then I'm using 2 10 amps for this, these motors. I believe these are 2 amp stall, so that leaves us with 6 amps altogether, because 4. But anyways, that gives us 5 amp for each motor, and I like that. Except for these are on 1, which I haven't had an issue. But this is what I was using for testing. Let's see if I could kind of show you guys the inside of one. So this is just a regular brass tube, kind of like this. Okay, and then I ground down the nut, the flange nut that this rod comes with. This is just a T8 rod. I ground that down, and then that allowed me to put it in here and then solder it. And surprisingly enough, it was really easy to solder this with just my soldering iron. I turned it up as much as it can go to 480, and cleaned this out in here. Made sure that this was able to slide in and out, and it was. Put it in, and then got it hot with the soldering iron, and then used some of this regular solder, and it worked. It works really well, actually. You can see it actually, it's nice and stuck. Works great. These ends, I printed these just like this, and then what I did is I made a template here, and this template allowed me to slide. I don't think this is too small, but it allows me to slide this in place, and then what I was able to do is just kind of hold it against something like this, and then drill with a 2.5 millimeter drill bit. And then this is just tapped, and then I grabbed a M3 tap, and then used these 12 millimeter M3 by 12 grub screws, and that holds that in place. And again, with the laminate, I know I keep saying this, but the laminate, the way that this is printed is it's printed like this. So I don't know, the idea that this would break is relatively unlikely, because of the way that it's printed. It would have to rip itself, as opposed to the other way where it can just kind of snap. So these have held up pretty good. I haven't tested it outside yet, but we'll be able to do that later on. And that's basically how that is done. I have a housing here. So this was for a bigger motor I was testing. They just became so, look how much bigger it is. Holy moly, huh? But the motor sits inside of here. This is the wrong motor. The motor sits inside of here, and then you get your threaded rod with the coupler. So this just kind of like this. Alright, this actually gets, with the coupler, gets attached down here, and then it spins this rod. And then we all know, what happens if this can't spin. When you spin this rod, you get our linear movement. So I thought it was pretty cool, pretty creative, and it's a good way to maintain the look of excuse me, the actual machine. You can see what I tried here first. I thought these would work. These are a lot skinnier, and man, they just look so much better. Unfortunately, these motors in here, I'm trying to see if there's a screw. The motors in here are just a little too small. Come on, guy. These are the 16 GAs. This is basically what I used for the Kubota, this rod. But I was trying to use the bigger motor. These are great. I think these would be great for like a 308, or maybe even like a 310 if they do that, 313 or something. I like these actuators. I like the housings and things like that. And Richard Turcotte did an awesome mod on the Kubota cylinders. He put the end stops inside, which is really cool. I'm not sure I have the patience to do that. All mine are in the arm or right here, and then one will be right here on the outside, like installed in here, and then get mounted right there, something like that. But thank you guys for tuning in. Again, I know it's a long video, but I just wanted to really go over some of the stuff that I'm doing with this and how I had everything set up, and I hope you guys enjoyed it. I hope you guys learned a little bit and it was useful. So look forward to getting this model finished and getting it out there and showing you guys what it can do, and letting you guys get to building it. So thanks again for tuning in, and we'll talk soon. Take care.